All right, everyone. Well, let's go ahead and get started with mean and standard deviation. Okay, so let's take some notes. So the mean is the total sum of the values in a sample divided by the total number of values in the overall sample. Okay, so for example, if we wanted to, look at Yvonne's text messages sent during class time for the last 12 class periods, well, here's the data. So what we would do is we would add up all the numbers, add them all up, and then because so then we'd get 385. And then if we go ahead and divide by 12, we will get 32.083. So remember that number because we're going to use it later. Okay, and then so a quicker way of computing mean, especially when you have a whole bunch of numbers, is to use Desmos. You just type in MEAN and then open a parentheses, and then you just enter all the values that are in the data set separated by commas, and Desmos will do it for you nice and quickly. Okay, and then I just want to remind everybody that the symbol for mean is mu. Okay, it looks like a U with a little tail on the front. Okay, there's another one. All right, and then let's talk about standard deviation for just a second. So it's the measure of basically how far away data is from the mean, okay? And so we have normally distributed. Okay, so this is typically how data falls. It's symmetrical about the mean, 50% above the mean, 50% below the mean. Then we have what's called right skewed. Okay, so that's when the tail is on the right, okay, when most of the data is over to the left, okay? And then we have left skewed, which is when the tail is on the left-hand side, okay, most of the data falls on the right side. Okay, so when data is normally distributed, it tends to fall within 3 standard deviations of the mean. Okay, and we'll talk more about this shortly. But the symbol for standard deviation is sigma. Okay, it looks like this. Okay, the Greek character sigma. And so let's just do an example. So if the class average is a 75 on a test and you're told that the standard deviation is 3, okay, let's draw the normal curve for this. Okay, so here's essentially what it looks like. You go +1, +2, +3 standard deviations to the right, and -1, -2, -3 standard deviations to the left. Okay, so for this data in particular, average is right in the middle at 75, and then we'll +3 3 times to the right, and -3 3 times to the left. Okay, and so the formula for computing standard deviation is actually pretty complicated. Okay, it's the square root of the sum of every value in the data set minus the average, the quantity squared. So add those all up and then divide by n minus 1, and then again square root that whole thing. N is the number of values in the data set. So for example, let's look at that data set we looked at before. Remember the average was 32.083. So you're going to take, for example, the first value in the data set, 12. You're going to minus the average or minus the mean and then square. Okay, and then take the second one and do the same thing. And then you're going to add those all up. Okay, add up those numbers. You're going to divide by 12 minus 1. You're going to divide by 11, and then you square root the whole thing. Okay, and you'll get about 9.83. Okay, but that's pretty complicated. So, of course, there's a quicker and easy way. It's a command called standard deviation in Desmos, STDEV. Okay, and so you just enter all the values in the data set separated by commas with that command out in front, and Desmos does it for you nice and easy. So let's go ahead and do the wee problem. Let's see if we can use Desmos, okay, to find the mean and the standard deviation of this particular data set. So if we just type in mean and enter all the numbers separated by commas, you should be getting 16.3, or you're welcome to do it the long way. And then all you have to do is delete MEAN in Desmos, keep your data set, and just type in STDEV, and you'll get quickly the standard deviation. Okay, so let's try it one more time. Oh, so let's take our data set and go ahead and sketch the normal curve for it, okay, based on what we just found with our mean and our standard deviation. And you should get this. All right, good luck. Get to the practice set.